Welcome everyone to my presentation on the new GibbsCAM Wire EDM module. This has been long anticipated and actually has a lot of features that people typically ask for from new and modern CAM systems, such as automatic feature recognition, giving you the ability to customize the product and then just let it loose on your part and have it do everything automatically, which is pretty cool. Going into some logistics here on how to activate it once you've purchased it. It is a plugin developed by a company called OptiCam here. And so it plugs into GibbsCAM and has a different interface than what you might be used to if you're an existing GibbsCAM user. So you need to go into the plugin manager and scroll down to O to make sure your OptiCam EDM is turned on here. But once that's on, you should have the toolbar here. Now this is grayed out because I haven't selected a machine that's compatible with Wire EDM here. So I'm going to go ahead and switch over to a vertical Wire EDM machine here, and you'll see the interface kind of change. Notably that we have a ribbon on the left hand side, and then also our OptiCam menu is now not grayed out. Okay, so I'm going to start off by showing you what everybody likes to see within the feature recognition here. So click that, select your part, and then you have the option of doing, external and internal, just external. I'm going to do both here and just hit that button, and we're done. It's looked at the entire part, recognized all the features, and automatically machine them per the settings that we set. Now, in this case, this is all out of the box. I haven't actually changed anything in my settings or manipulated anything, so this is exactly how you would see it right after you install, and I think that the default settings are pretty good as well. So let's go ahead real quick and just simulate this and see what it did by itself. Now, we have these cylinders here. You might have noticed these are just ruled surfaces, just extruded circles effectively, that were created in the CAD program that the designer created this part with. And OptiCam recognizes these circles and automatically uses them as start points. Now, if you don't have these start points there, it'll go into your rules and your settings and figure out the best start place for the type of shape that it's trying to cut. So it's pretty intelligent there, but this is a nice little way that the CAD designer can force automatic creation of this kind of thing in OptiCam. So let's play it, and it always starts at the origin here. It's going to wrap it over, automatically thread the wire, and then go through a profile here. It also stops short of cutting it off. That's where you would have your glue stop, your bridge, so to speak. So and then you can remove the slug and continue on, automatically cutting and rethreading your wire as it goes along. So there's no manual activation, no putting in those codes. And you can see it's pretty intelligent. It's got a pretty good default order that it did these pockets in. It optimizes the order automatically as well. Of course, all of this you can go back and change pretty easily, and I'll show you how to do a lot of that in this presentation as we get further along. Okay, so there's our part. Again, probably took 15 seconds to really machine. And again, if you go through and you set everything up, company standards of how you like to do things and all this kind of stuff, literally anybody can run this product. You could have your intern press the check mark. It's really that easy once it's all been set up and standardized and that kind of thing. So really cool stuff. I'm sure you're wondering, well, if I do have to change things, how do we do this? So I'm just going to kind of go through this cam view ribbon on the left hand side and show you piece by piece what each one does to give you a feel of what you can do with this product here. So starting here, this is your origin, and you can manipulate the origin, change it to where you want. You can either do this on a global basis, which is what I'm doing right now, or you can do this on a individual operation basis. So if you want an offset for a particular operation, however you want to do it, it's really easy to do. Just click this vertex edge, and anywhere on the solid model that you want, you can click and kind of just leave the origin there, and it's that easy. You can also enter explicit origin coordinates. Nothing too interesting here. Now, when I'm going to leave it how it was, but when you bring in a file, it typically puts the origin at the bottom middle of the part, so which is generally where you want it for Wire EDM. So that's good as well. Moving on to strategy here, it doesn't quite make sense to talk about a strategy on a global scale here. So this is actually going to be within the operation, and I'll talk about that here when we get down to it. Technology, this is effectively how you're cutting your part, right? So I come in here and I set up, hey, I have a 0.25 millimeter wire diameter. It's made of brass. I'm cutting steel, all those kind of things. I have one cut here by default, but it's really easy to change and customize that. We have something called the cuts editor. So you check this box, and then we hit the cuts editor here. And this is really where you control how it operates in any given operation. So if I want more cuts here, I can turn on, cuts 2 and 3. Let's say that, maybe I want to start, somewhat far off and kind of get closer and closer with my laps. Take a little bit more off, something like that. These have to do with the post, the generator and offset register. Don't worry about them too much, but the post I'm going to use in a little bit requires these to be filled out here. And so any of these check boxes, these categories here on the left can be checked on. So if I'm concerned about the feed rate on one of these cuts, so I can just check that on. You see it adds another column to our cuts editor where say, oh, maybe on this first cut, I'm worried that this is a little too fast. So I'm going to bump that down to, say 7 millimeters per minute or something like that. There's a lot of control you have over individual passes, not just the entire operation. So really anything you want to do regarding to any of these categories. And then once I've got this all set up, I can either just hit the checkbox and apply these to our operations, or I can save the user tech here as a separate file. And that way when I'm doing another part, similar part, something like that, that maybe involves still brass wire and steel parts, I can just load this tech in. I don't have to fill this out again. So once you kind of develop a company standard, anybody can import these and operate this Wire EDM CAM program. So it's pretty cool stuff here. So I'm going to check that box here, and then I'm also going to check the box here. And now when I go into my one of these operations, these toolpaths here, you'll see that automatically I have the 3 passes, and before I only had 1. So I didn't have to regenerate these operations or anything like that. It just kind of automatically did it because I was working with this technology, and this operation and this section of the operation belongs to this technology. Okay. So moving on, our last thing here is the workpiece. This is in fact your stock, something like that. The standard setting is to use a offset box around your part, and you can change the offsets here. So if you need some extra stock on one side, this is where you would change that. Alternatively, if you had some work done before you put it on this machine, maybe you drilled a hole or something like that, you can import a solid to use that solid as your stock as well. And you would do that by checking this box here and then selecting the solid that you have. Okay, I'm actually just going to leave it how it was. But yeah, so this origin is where you would go to change the origin just for this particular operation. I'm not going to talk too much about that. Strategy, this is kind of the order that you're doing this operation, so how to optimize it, maybe some extra features. So we have, you could do collar before taper, taper before collar kind of things. Make sure that you are reversing cuts when you have more than one cut. You can cut all the bridges at the end of the program, or you can do it on an individual pocket basis. All that kind of stuff is in here. I'm going to show you how to optimize our route here. So I'm going to say routing optimization. And you can see here that the length of our toolpath right now is about 278 millimeters. So what I can do is kind of reorder this how I want. Now this isn't necessarily a bad way to do it, but there's any number of reasons why you would want to reorder your operations. So I'm going to start here, and I'll say I'm going to end here on the outside, and then hit calculate new, and it'll automatically regenerate the path here. And you can see it's a little bit different. And our new toolpath is 270 millimeters long, so we've taken a tiny bit amount of time out from what it automatically generated. So that's good, and that was fairly easy to do. I wasn't picking explicit points to where I wanted to go to optimize. It's kind of just a two-step thing, so pretty easy there. This technology is actually using the program technology. However, you can overwrite that, so if you want to do something different in a particular operation, that's where you would do it. And then we're also using our program workpiece, so we don't have to talk about that. We also have inside these what they call features, so portions of our operations, we have some control over what it does. So maybe in our before moves here, I can add an event. So if I say add move here, so it's already rapiding from the home position, but maybe I want to thread the wire, right? So I want it to come from our origin, come over to this feature to our start position, and then I want it to thread the wire, right? But actually you don't need to do this. It's all done automatically, and this is more just for like manual control, make sure that it's actually doing it properly, or maybe you want to do it in an unorthodox way where you have different orders or something like that. This is how you would control that. And then likewise, like before moves, we also have after moves. So, after it's done cutting, maybe I want to raise the nozzle a little bit for clearance or something like that. We also have lead in, lead out here. So a lot of different controls in here. So we also have that, endpoints, and then lead in, lead out here for this particular operation. Now my lead in is all grayed out here because I do have a starting point defined, so it's going to follow that, but I can lead off, do an arc out, something like that. So this is where you control all that kind of functionality. Pretty basic, pretty self-explanatory. Corner relief is kind of a cool thing. Now this design already has some corner relief built in, this particular feature anyway, but I have a lot of different options here for corner relief, for maybe like this middle pocket if I wanted to, where I say, circular loop, and then I can define the radius of the loop to give it some relief. So all that kind of stuff is in here, and it's nice that you can modify the toolpath like that while still maintaining the original solid, the original design intent here. So that's cool. That's where you would do corner relief. And also we have a little bit of pocketing if you want to destruct the slug after you're done machining. So that's where you would do that as well. So I spent a lot of time talking here, but really it took me less than 10 seconds to program this part how I wanted to, especially if I had already saved that technology and imported it. So really powerful stuff. However, this is a pretty simple 2.5D part, right? So I want to move on to something more complicated. Let's do a 4-axis part here. I'm actually going to start from scratch, so I do a new file here, and I'm going to import a parasolid file, which is just a basic solid model. And I like to, when I bring things in, change the chord height so that the graphics look a little bit better. This actually doesn't affect the toolpath at all, so now it's a little bit smoother, but that's just personal preference I have. And then I also like to shrink wrap, so we're getting a lot of this stock out of the way that we're not going to be using. So here's our part. It is indeed a 4-axis part. If I get a top view, you can't really tell, but it does have a 5-degree draft if you're looking from the bottom side here. Okay, so this is a 4-axis part. And I could do the automatic feature recognition, but this time, just to show you, I'm going to do the manual feature recognition for that reason, and then also because if I did the automatic feature recognition, it would automatically do the outside, and in this case, I just want to do this. So I'm going to select the face where I want to start, and it automatically creates a start cylinder based upon my default settings that I have in OptiCam, which I'll go over here in a second. But then I just hit this green check mark, and again, we're done. Instantly, pretty easy, pretty powerful stuff. If you're familiar with a lot of other Wire EDM solutions, a lot of times what you have to do is sync the top and bottom nozzle, right? Because let's take a look at this while I talk about this. You have to sync the bottom and the top nozzle because they're not going to be on top of each other due to the draft. But you can see here that the top and the bottom are moving independently, and they've already been synced. All that has been taken care of, which is really nice. There's little room for human error, so to speak. So, even if I know what I'm doing and I'm syncing these points, a lot of times maybe you misclick or something like that. This kind of automation prevents a lot of those human errors. So it's a lot safer. And you saw that it stopped for our bridge, our glue stop. But that's the end of the program there. And pretty simple, but I like it. So again, I manufactured this part in 5 seconds or so, but we do have more options here I'd like to talk through on the OptiCam menu. Most notably the post processor and how posts work in the new EDM here. So I go to select post processors, and then you get one post processor with your purchase of the GibbsCAM Wire EDM module. And actually, all the post processors are built into the product when you buy it. So there's not any going to the post department and, hey, I need a change here, I need a change here. It's all already in there, and you also get a little bit of manipulation that you can do as well here. So I'm choosing a Mitsubishi machine, Mitsubishi post, and once I go back into select a post processor, I can select my type of machine here. So we're using an FXA here, and then I can load it in, right? And you see now at the top of my program, it tells me, hey, you're using a Mitsubishi post. And actually, a couple things change below this when I do that. So let's open up our technology. You can see that now we have like a Mitsubishi logo here, and I can load some technology. So the new Wire EDM product also comes with a little small database of manufacturing technologies or strategies, so to speak, where there's a couple thousand in here, and this is exclusively just for Mitsubishi machines. But let's say, I know I'm using brass material, I know it's going to be 0.2 millimeters, and I know I'm cutting steel, right? I don't care about any of these other programs or parameters rather, and so I can just say search, and here are all my search parameters that match what I search. So even within this very specific thing that I put in, we have a good deal of about 200 different strategies. So I'm just going to pick one. I want 3 cuts, so I'm looking at the number of cuts column here. I'm going to pick this one because I think it looks good. You can, again, save all this when you do your cuts editor if you have any kind of standards, but this is another way to do it pretty easily. And you see that here are the 3 cuts and the offsets that they have, all that kind of thing. So I've loaded that in, and automatically, again, my operations have been redone. So you can see now there are 3 passes here. And if I go into graphic simulation, actually I want to make sure that I am reversing cuts so we can see that option. But let's go ahead and re-simulate. Okay, and then it's going to do a reverse cut. Now, I noticed that it did cut the bridge there. How you change that is also in that strategy menu. I'm not going to bother with changing that and showing you again, but that's where all of that resides as well. So cool stuff with the post processors. I'm pretty happy about that. Another thing that I like here is that you actually can do some manipulation, as I talked about before, on your post. So if I wanted to, maybe create a setup sheet, I wanted to add a comment for each cut, or any of that kind of thing, you can see that there's a good deal of things that I can change myself without actually having to go to the GibbsCAM post department or any post department. I'm not making edits to the post myself. All this is kind of right here with check boxes and really nice, including your, your metric or your units and that kind of thing. So that's all there, and you can change it on the fly whenever you want. So super handy, super cool stuff. When I actually output my file here, it not only generates the NC file for me to put out to my machine, I have it generate a setup sheet here, and you can see that it has all the information, including like the angle of our draft or taper here, all that kind of stuff. A lot of information in here, and I believe some of this is customizable as well. So that's pretty cool as well, pretty handy for whoever's setting up the machine to know as well. So that's how you post things out. One more thing I'd like to talk about before we end this demonstration is our settings here. These settings are typically things that you just set and don't touch again, but you can. So we have our units, we have tolerances. One thing that is coming soon to GibbsCAM Wire EDM is the ability to recognize colors. So this comes in handy when your designer, whoever's designing this part in their CAD program, can take and apply different colors to different surfaces on the model. And then when we import that into Opticam, and it automatically recognizes these colors and will automatically machine those features based upon the color. So you would have, maybe a yellow color that represents certain tolerances, where a red color might represent, a tighter tolerance, something like that. And all that will be automatically done for the technologies that you specify for each color. So I'm really excited about that. I think that'll help a lot of people out as well. We have a lot of start hole settings here as well. Now this is based on the shape, either the internal die or the external punch, but you see we have a lot of shapes here. So what I could do is say, hey, if you find a quadrilateral, I want you to always put the start hole 2 millimeters from the largest side on this quadrilateral, or something like that. And I could do that the same thing for the external punch. And it'll automatically use all these settings to do that. So you take a little bit of time and fill this out the very first time you use the Wire EDM. The automatic feature recognition will be a lot better from there on in. So that's pretty cool as well. And then last but not least, we have feature recognition settings. This is where I can, if I don't want to do maybe 4-axis, I can check that off. And then when I do the feature recognition, it's not going to find anything that it needs 4-axis to do. So that's the end of the settings, but I think I showed almost everything that we have right now. It's pretty simple to learn, and it's also pretty simple to master, but we still have that power and capability to do whatever you need to do within GibbsCAM Wire EDM. So I'm really excited about this project, and I hope you guys are excited to use it as well.